Hi, welcome to Flipped Classroom episode number 2. Follow along the video and do the following questions. Triangle ABC was mapped onto triangle PQR by a rotation. Using a compass and straight edge, construct the center of rotation and label it point J. To construct the center of rotation, we will do 2 perpendicular bisectors. To do a perpendicular bisector, we will need to connect corresponding points to make a line segment. The first perpendicular bisector will be from A to P. Once you have your line segment, you're good to go. Put your compass on one of the end points, a little bit more than halfway. Jump to the other end point. Here is your first perpendicular bisector line. Try to make this dark so it stands out. This construction gets pretty busy on the paper. The next set of corresponding points would be B and Q. You're going to connect points B to Q to make a line segment. You need to do another perpendicular bisector between endpoints Q and B. Okay, line your straight edge up right through those intersections to make your second perpendicular bisector. You are looking for where your perpendicular bisector lines meet. That is going to be your center of rotation. Label it point J. So if you think about it, this triangle is rotating around point J. I might be able to show you this with some trace paper. Yeah, this is going to work. So here's my trace paper. I'm going to trace out this triangle. Okay, let's see if this rotates. Okay, so generally, that worked out pretty nicely. That's pretty cool. Okay, so this is my center of rotation. Part B, state a possible name for the angle of rotation. The angle of rotation would be from A to J to P, or any other 2 corresponding points. So this is definitely, an obtuse angle here. Angle A, J, P. Okay, so that's the first construction of this flipped classroom lesson. The second construction is actually doing a rotation. Now, to actually do a rotation, they have to give you the reference angle. This one is going to be a rotation of 110 degrees. You can't do it without your reference angle. Must be given. Okay, rotate point D around point O counterclockwise by the given reference angle measure of 110 degrees. Guys, this is something you've already done. You're going to copy an angle. So you need to copy 110 degrees off of point O. To copy an angle, you put your compass on the vertex and you swing a loop. Okay, actually, I need to make my ray here. Make the same size loop. Okay, You should see on your reference angle your loop hit twice. We need to take this width and copy it over. So how wide is 110 degrees? Copy it over here. Oh, I just made it. Okay, now here's my 110 degrees. Where is point D? Point D is not necessarily at that intersection. You have to see how far down the ray point D is, and then you're gonna, transfer that over. This would be D prime. So you guys are doing a construction, you already know. Copy an angle and then figure out how far down the line D prime is going to end up. Okay? There's another one of these on the next page. Let's give that a try. Oh, there's two more. Construct the image of point X under a counterclockwise rotation around point B by the measure of angle A. So this right here is your reference angle. We need to rotate point X by this angle amount, counterclockwise, okay? So you need to copy an angle again. This time I need to make sure I start with my array. Okay, you're going to copy angle A. You want to do a loop. You want to do a loop. You need to measure how wide is this angle. Transfer it over here. Now look, I'm not on point X right now, I'm just on my loop. Okay? Here is the angle. Point X is going to fall on this ray. Now you need to figure out exactly where it's going to fall. So you're going to measure X. X prime is going to go right here. Okay, so you can pause if you need to, go back to those two. Okay, number 9 is rotating a line segment. Segment BC is being rotated around point A by an angle of B prime. The location of B prime has been determined. Use this angle to construct the position of point C prime. This is my center of rotation. It's also my vertex point. Sorry. Okay, so here we go. This is the angle. B is rotating around A by this angle amount. I want C to connect and rotate by the same angle. Okay, I'm actually going to do C. Let's do C in a different color. Copy this angle off A. Okay, so I'm going to do my loop. I'm going to do my loop. Okay, here's my points that I'm measuring. here to here. Okay, here's my C line. I'm going to go back to orange. So my C prime should fall on this orange line right here. Where does it fall? Well, we got to figure out how far down, how far apart are these 2 points. Because when you rotate, you know, all these distances should stay the same measure. I mean, here's really what's happening. C is rotating up to there. Okay, then we need to finish with our line segment. So this one got kind of crazy. We can actually even highlight our answer. This is my answer. Okay, so I took this line segment and I rotated it. Okay?